Okay, so here we're looking at radical expressions. And so we want to just be able to simplify these as much as possible. And when you're looking at a radical, depending on the type of radical in terms of the root. So this is considered a square root. We never write the 2 on the square root. We do write for all the other numbers. So the first 2 here are square roots, and the last one is a cube root. So that means in each, the root is letting you know how many you need to be the same in order to come out of the root. So the square root means you need 2 of the same factors in order for it to come out of the radical to simplify. So what you should do is really just use prime factorization and break your numbers down into their prime factors. So when I break down 9, I get 3 times 3. Well, that is a pair, and that means that pair can come out of the radical. And so the square root of 9 is a 3. Okay? So then we have the square root of x to the 6th power. What does that mean? That means we're trying to figure out how many groups of 2 x's are inside of 6 x's. Understand that? All right? So that's why when we did 9, we pulled out a single 3, because that is letting us know that there is a single pair of 3's in a 9. So how many pairs of x's are inside of 6 x's? So you can break it up. 1, 2, 3. 3x to the 3rd power. All right. Now, the shortcut is to take the nth root and divide it into the exponent. So this is a square root, and we ask how many 2's are inside of 6? 3. So that lets us know right there that there are 3 groups of x's, and that would be your answer. So then let's go to the square root of 12, xy to the 5th power. So we're going to take 12, and we're going to do the prime factorization. So you just start with any 2 numbers that come to your mind that give you 12 when you multiply. So 4 times 3. And then I can break 4 down, 2 times 2. So once you have only your prime numbers, then you're going to put them there. So how many pairs? I see a pair of 2's. So that means the 2's can come out. 3 doesn't have a friend. He doesn't have a twin. He cannot go out. He has to stay home. X, y to the 5th. So when I look at x doesn't have any pairs. So, and also 2 does not divide into 1. So the x's will never come out. We have y to the 5th power. So that's 5 y's. How many pair of y's is inside of 5 y's? That's what that means. So you can draw it out in circle, or you can do your little division. 2, 1 left. So that means that y squared comes out. Your remainder is the exponent of y's that stay in. So 1y stays in. So our final answer is 2y squared square root of 3xy. And that's it. Okay. Next, we have the cube root of 54 a to the 6th, b to the 9th. It is a cube root. That means that we need triplets. You have to have 3 of the same in order to leave the radical. So we're going to break down 54 into its prime factors. 6 times 9, 2 times 3, 3 times 3. All right, so 2 times 3 times 3 times 3, A6, B9. So let's see. I have 3 3's. So one of these is going to come out. 2A6, B9. Now I'm going to take care of my variables. So how many groups of 3A's are there inside of 6A's? Understand what that means. That means if you count out 6A's, how many groups of 3 do you have? 1, 2. So that means A squared is coming out. If you want to do B9, I'm not writing out 9Bs, okay? If you want to do that, you can. I'm going to use division because it's the same thing. 3 divided into 9 is 3 with nothing left over. So that means B to the third is going to come out. And I would be left with simply the 2 who has to stay home by himself. And that would be it. All right? And that is 10-1 and 10-3. All right? And remember, I love math, and so do you. And you should say that all the time.